How to build a Blackgates Sweet Pea 5-inch gauge locomotive, part 42. Both of the cylinder bores have a very slight taper. I use a cylinder hone to correct this and reduce the diameter of the pistons using Emery Cloth. Once again, I refit the silicone piston rings. This job demanded a lot of patience. The cylinder covers were on and off and the pistons were in and out. And this is not the last time that the pistons and cylinder covers will be fitted. I have to remove them again to make the glands, which are not right. I'm not going to run too much of this video at a higher speed, but routine things like undoing bolts that hold cylinder covers to cylinders and refitting them are definitely better running at a higher speed. This part of the video is actually running at half speed, nearly slow motion. What I'm doing is removing the cast iron piston rings without breaking them and showing you how I do it slowly and carefully. The piston rings are fine, but unfortunately both of the cylinder bores do have a slight taper. That's probably due to the parts being machined on a lathe that either wasn't set up right or didn't cut true. It's only a very slight taper though. Here are the two cast iron piston rings, and as you can see, they're definitely not broken. I'll put these in a box for the time being. I may reuse them. It depends how good the silicone piston rings are. I don't want to risk scoring the cylinder by using piston rings that are too tight in the bore. Even though they are only tight at one end, it's going to put pressure on the system, so the silicone rubber piston rings are a better idea, at least for running in. The other advantage is it looks like the grooves in the piston were turned slightly oversized to use silicone rubber piston rings. With the cast iron piston rings fitted, I could actually feel that they were slopping about. So that's where we are at the moment. Silicone rubber piston rings, and now to tackle the bores. When I say that the bores are tapered, I don't mean like a cone. We're talking a very small amount, and here I'm using a cylinder hone in my DeWalt electric drill to clean up the bores. And I'm concentrating it slightly on one end more than the other. On both cylinders, the taper is always at this end of the cylinder. Now when I try a test fit of the piston without the rings, I can feel that things are slightly better, but the piston is still a little bit oversized, and the answer to that is put it in the Myford lathe, use some Emery Cloth and just give it a bit of a polish up. And once again, I'm not removing much metal at all, just cleaning off the machine marks. It would not be a good idea to remove too much metal from the piston. Here's a shot of the cylinder bore after I put the hone through it, and you can see everything's really shiny. The finish is very good indeed. After using the cylinder hone, it's really important to clean out the cylinder. I've just sprayed some 3-in-1 oil into the cylinder and I'm using a cloth to thoroughly clean it. And now a quick word about cylinder lubrication. If you're using silicone rubber, you must use the correct type of oil. Certain oils and solvents attack silicone rubber, but this high-quality steam oil does not. Even if you're not running your steam engine using steam, you still need to use the correct type of oil. Superheater cylinder steam oil. It's very thick, has a lot of drag, but it doesn't damage the rings. I've fitted the piston rings to the piston, and again I've applied lots of steam oil, both to the piston and to the cylinder bore. With the video running at a speed of 400%, I'm tightening 3 of the bolts that hold the cylinder cover in place. Both the piston itself and the silicone rubber piston rings are a good fit in the cylinder. When I block up the ports with my finger alternately, it's impossible to move the piston until I remove my finger, and there's no tightening up of the piston in the cylinder at the end of its travel. Here I'm demonstrating how the piston moves back and forth by blocking off most of the ports and using my air line to blow compressed air into the cylinder, and as you can see, the piston goes back and forth very smoothly. As I've mentioned before, the workmanship standard on this engine is not particularly good. That's why I bought it, because not only am I showing you how to build a Sweet Pea, I'm also showing you how to repair and rebuild one. If you build one yourself from a kit of parts, that's one thing, but it's always good to know what's going on with things that are not made correctly. And more importantly, how to fix the problems. I should really know better. I've bought various engines that were part finished in the past. One in particular many years ago, not the one I ran around my garden, but one that I had previously, was a 7 1/4 inch gauge titch. I bought it part finished with a very nicely made boiler, but the frames were 1/8 of an inch longer at one side, so the axle box slots didn't line up. How did I fix this? I banged it on the garage floor with a lot of force, which eventually straightened the frames. When I built the rest of the engine, I had to allow for the fact that one side of the frames was 1/8 of an inch longer than the other, but apart from that, I finished the engine, ran it for quite a while, and I finally sold it many years ago when I sold most of my models and my workshop to finance the deposit for a house. I re-drilled the hole in a different place in the top of the cylinder cover. And even though it looks like it's in the wrong place, it isn't. This cylinder cover casting is not good. It's not quite the right shape. If this part of the job is successful, then it's all well and good. But if the crosshead guide bar on this cylinder is still out of alignment, I will make a new cylinder cover. Having said that, I've noticed that there is a problem with the size of the glands. More about that in a future episode. Personally, I do not like the gland arrangement on a Sweet Pea Locomotive, but for the moment I'm going to work with it. Here once again at a high speed, I'm refitting the cylinder cover. And here I'm fitting the crosshead guide bar at the other side. And even though it doesn't look right on the top of the cylinder mounting, it seems to work and the piston slides back and forth. I made a temporary slipper, but this is too thin, and I'm going to make some proper slippers using a more suitable material. That is it for this episode. Stay safe, stay healthy. Thanks for watching, and I hope you found it useful. Please take the time to visit my Mainsteam Models website and click on the section of the website that says Video Playlists. And by doing that, you can find other videos that you may like to watch. And by using the playlists, you can actually watch the videos back to back.